Today we are going to deal with a general result. What does that mean? There is nothing special about this triangle. The result that we are going to prove is going to work for any triangle under the sun, even the ones you meet in the supermarket. This result is going to be applicable to every other triangle. Now what do we have? As usual, we have taken a triangle. We have denoted the vertices by capital alphabet and the measure of the sides by small alphabet, which corresponds to the opposite vertex. Now what are medians? Medians are the line segment which join any vertex to the midpoint of the opposite side. So the median which comes from A, I will call it MA. Similarly, you are going to get an MB and an MC. Now these three medians intersect at a point called the centroid, and I have denoted it using the alphabet O. Now what this centroid does is divide each of these three medians in the ratio 2:1. So that means, for example, if you take the median MA, which corresponds to the vertex A, suppose you take the median MA, what this point O does is divide it into two parts, one of which is going to be 2/3 MA, the other is going to be 1/3 MA. That means you have two unequal parts. One part is going to be bigger. Now the question is, which part is going to be bigger? The part which is closer to the vertex, not the one which is close to the side. This part is going to be the bigger part. And the same with MB. The one which is near the vertex is going to be the bigger part. So here we have just stuck with the bigger parts. Now what we are left with is our triangle and three line segments which are 2/3 of their original corresponding medians. What else do you notice? This point O here, the centroid, divides the triangle into three smaller triangles. Let us consider them one by one. Let us start with AOB. The sides of that triangle AOB look like this. And what do we know? The sum of any two sides of a triangle is greater than the third side. Then you will get three such inequalities. All the three of them are true. But which one do we choose? The one which gives us the answer. We are looking for an inequality which has the perimeter, the sum of the sides of the triangle in the lesser side and the sum of the medians in the greater side. There is only one inequality which will give you that is the first one. So that is what we stick to. Similarly, we'll go to the other two triangles also. Now actually you don't even have to look at the illustration or wonder about what is happening in other two triangles. You can see that there is a pattern here, right? There is one side and the sum of parts of the other two medians. That is the pattern that we notice here. If you have a side here, it will be the sum of the parts of the other two medians. So even without looking at the picture, you can write this. So you have three inequalities, add all of them. Here you have the perimeter, and here what do you have? Add them. You have 2 times of MA plus so this is the answer that we needed to find. That is all for today. Assalamu alaikum.